Hey everybody, Gabe Jenkins back with you. Hoping you're having a good time with AutoCAD so far. I want to just show you today we're going to be working on a drawing number 9, which is kind of a complicated drawing. I'll be honest with you. It's going to end up looking like this, and so there's a lot of things that I want you to kind of get out of doing this assignment. And so before we get started, I want to just start by saying, you can think of how to do this drawing in a gazillion different ways, right? And like everything you do in CAD, there's not like a right way to do it, like a right order of operations that you have to do this first, then this second, third, fourth. And I've noticed that sometimes you guys come up with stuff that's like really more insightful and more creative and more direct and efficient than the way that I think about them. And I think that's great. Because I can learn from you guys when you guys do it a way that makes more sense to me. Happened a lot in the key assignment. And it might happen again with this one. So I'm going to tell you how I think about this shape and then and what I hope you to get out of it. And then I'm going to let you kind of do some work on it, okay? And see if you come up with something better than I do. So here's the shape itself, right? Here it is in AutoCAD. Here's what it looks like. And so here's the way I think about this shape. I take a look at it and holistically, I'm seeing that there is a large rectangle with dimensions of 200, and then it says from the middle of that shape down to the bottom is 76, so it's 200 by 152. From top to bottom is 152. I see a smaller square shape in here, and from a point in here, it is 59 down and 59, well, theoretically, we'll say 59 up. There's a lot of stuff in here that's not super obvious, though, like where it's located right out off the bat and the sizing of things, right? So I see all of the bigger rectangle out here have filleted corners, and it says here that there's 8 times a filleted corner with a radius of 12. Now, obviously, the rectangle only has 4 corners, and so because it says there's 8 of them, I'm going to assume that this fillet, all the fillets for that kind of smaller rectangle or square, whatever this ends up being, those fillets are going to be the same as the fillets for this outer rectangle. So I'm going to assume that all the fillets here, 1, 2, 3, and 4, those are going to be the same radius of 12 that these are here. It also has got this here where it says that the fillet here, the radius is 8, and it says that there's 6 of them, right? So I'm going to assume that this fillet is 6. This fillet is 8, this fillet is 8, but that's only 2 out of 6 of them. So I'm going to assume that this 1, 2, 3, 4, these semicircles, I'm going to assume that they also have a radius of 8. This says there's a 6 times a radius of 4. They should really say 6 times diameter of 8 here, to be honest with you. They don't. But so that means that this circle, that one, that one, and that one all have the same radius of 4 or diameter of 8. Okay, so those are the sizes of things. I see that I got a bigger circle here with a little cutout part in the top, but a bigger circle with a radius of 44, smaller circle with a radius of 27. And it looks like I have like a little box, like a little rectangle here that's 38 wide and 32 tall. Now, where all those go is going to be up to you to read the dimensions super, super carefully, okay? It looks like the center point of that circle is going to be 134 units away from the right edge of this bigger rectangle, 134 from here. So let's just say I had this line that went from here all the way to here, and I offset it 134 over to the left. Okay? Then if I took the bottom edge of that rectangle and offset it 76 up, I would have a line that goes horizontally this way, and that would give me the center point, the intersection of this offset line and that offset line. The intersection of those two would give me the center point of both of these circles, right? So that's a good starting point. That helps you to set where these two circles go and helps you also to figure out where to set this rectangle up top. But lastly, we have these kind of like little circles with, I don't know, semicircles and lines coming off of them. Now, we know that the center point of that circle is 40 over from the left side. So if we offset this edge over 40 with a construction line, and the top of this line right here is the center point is 8 millimeters up from this edge here. So if we offset this line up 8 and offset that 40 over, we would have an intersection of two construction lines, which would give us the center point of that circle. We do the same thing, but offset this line over 60 more, it would then give us the center point of that circle here. We can mirror all of those down across this horizontal, this line right here, and then it'll give it to us down here and down here. So there's a lot of construction line work that will help you to find the locations of where all of these things go. It's a lot of work. It's a lot of thinking. It's a lot of, it's not a lot just like straight drawing. There's a lot of like prep work that you have to do with construction lines in order to get to the point where you can draw the visible object lines in the right spot. So it's a lot to take in. And so that's my first video, and I'm going to leave it there for now, just so that's how you can think about it. If you want to try to follow along with me as I do all of that work with you, I'm going to put that on a second video, which I'm going to attach. Okay?